All right, so today is our last lecture. Thanks for coming. If you want to see more review problems here, we're going to continue with the advent of code as we've been doing for, at least we tried to last time. It was down. It looks like it's up and ready to go here. If you're interested in the first few days there, I did them in the other sections, and I redid some of them. So if you're interested in those, go ahead and watch the live streams from those other sections. Otherwise, let's go to day 4 here. I've not solved this one yet. I have read it. I read it in one of the other sections. So we'll go ahead and skip the story here and instead just go immediately to the problem. The problem is that you're given these sequences of numbers, right? I don't even remember what the story behind them is, but basically this is a range, right? Let me go ahead and zoom in here. This is a range from 2 to 4. This is a range from 6 to 8, and it's inclusive on both ends, okay? Now, a visualization of this would look something like this. 2 to 4, 6 to 8, okay? Those do not overlap at all, right? 2 to 3, 4 to 5, those don't overlap at all. Now, 5 through 7 and 7 through 8, those overlap in one spot, right? This other one here completely overlaps the other, okay? And this one is completely overlapped by the second, right? So 6 to 6 is still going to be an interval. It's just that one point, okay? Now, what you want to do is with your input, an input looks like this. It's going to be the first range, A to B with a hyphen, a comma, and then the second range, X to Y with another hyphen there. You need to count up the number of these things that fully contain the other, right? So what that means is, well, this one doesn't have any overlap. Neither does this one. This one has partial overlap, but it's not fully, one of them is not fully covering the other. This one is, so that counts as 1. This one is as well, so that counts as 2. This one is only partially overlapped, so that doesn't count. It wants you to report that sum, that 2, okay? I've not gotten my puzzle input yet, so let's go ahead and go over here, and there it is, right? So a lot of these things, I think maybe 1,000 or something like that, right? And you'll note here that I don't see anything greater than 99, so definitely integers. I don't know if I see any zeros by themselves, but we can check that out later, okay? I'm not going to start with that input. Instead, I'm going to start with the test input here, because I don't want to submit my answer, get a wrong answer, and then be throttled for a minute. Right? Let's go ahead and test for that one, okay? First of all, I'm going to have to put this into some sort of a file. So let me go ahead and put this into a day04.testinput.txt. Right? And then I'll copy the test input there. And I'll get another file here, day04.input.txt, which actually represents the actual input, which I'll just go ahead and copy over here now. Right? Note there are 1,000 lines there. Okay? So I'm going to have 1,000 ranges here. All right, let's come over here and let's review by doing some file I/O. We're going to want to open up that file, read it line by line by line. But before we do that, let's look ahead, right? How am I going to determine whether or not there is a complete overlap like this or not? True or false? Does one completely overlap the other? Well, before I even get there, let's write a function and test that function, okay? So I'm going to have a function called completely overlaps. There we go. What should my return value here be? I want to know, does that one overlap that one, or is it the opposite? Right? Does one overlap the other, or not? What kind of a return value are you thinking about there? An integer, because you're thinking about a true or false. So we'll go ahead and go with integer. But you know what? What else could we bring into to play here? Bool, std bool, I think it is. Right? And that way I could return a boolean, true or false. I could use the keywords true or false. Right? Right? I don't know why you're complaining. You shouldn't, just felt quiet. Oh, duh, std boo, right? Scary. There we go. All right, I'm going to take those two intervals. I'm going to take, say, from A to B and from X to Y. Now, how do I know if those overlap or not? Let's look at the visualization here. Right? So on the left interval, right, one of them will be at least as greater than or equal to the other one. On the right interval, one of them will be less than or equal to the other one. Only if both of those conditions are true does it completely be contained by the other one, right? In other words, if A is less than or equal to X, right? So on the one end, X is now contained in A, and we want to make sure that Y is contained in B, right? So only if both of those things happen, in other words, a conjunction, an and, right? And Y is completely contained in B, right? Then return true. So think about this visually here, right? A, X, Y, to Y, and then somewhere over here, B, right? It looks something like this. Right? X could be equal to A, Y could be equal to B, but that's okay. It's still being contained according to the example input. All right? That's X and Y being contained within A and B. What about the other one? A and B being contained in X and Y. So let's copy that and put an else if, right? And switch these around, right? A is going to be A to B is going to be contained within X and Y. And if that's the case, return true. Right? Is there any other possibility? No, they could be completely out of range. There could be a partial range here. There could be a partial range on this side. It could be completely out of the range on this side. But by taking care of those two cases, I'm taking care of all those cases. False, 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 false. Right? So else return false. There we go. Now, before we move on, can I optimize this code? Can I change this code so that I don't have 1, 2, 3, 4, 5, 6, 7, 8 lines? Can I do this in fewer lines? Can I play some code golf here? Well, by getting rid of your cruft, right, you just cut it down one line. Right? What about these two conditions? If this is true or if this is true, then we return true. Could I combine those two into some statement? This or this, and I don't have to have an else statement anymore. Right? Else if statement. All right, I've got it down to 1, 2, 3, 4, 5. Right? Is there another way that I could cut this down even further? Okay, how? In fact, I could remove the if entirely, right? Why? Oh, okay, I see what you're saying, right? If that's true, then we immediately return and get and jump out of this function. You're down to 4, right? Can you go even further? If this entire expression is true, what do you return? True. If the entire expression is false, what do you end up returning? False. So if true, return true. If false, return false. Why don't you just return that thing? Right? In other words, return this thing. Got it down to 1. And then too many parentheses. Right. There we go. Great question in this morning's class when we thought about this was, are those parentheses necessary? What do you think? They're necessary for readability. That it shows intent. But if you look up precedence operators, the AND operator, the conjunction, happens before the disjunction, the OR operator. So by removing these, you don't change the logical value of this expression, right? This AND will be evaluated first, and then this AND will be evaluated second, and only then will it be the OR be evaluated based on those results. But that's a hell of a lot more readable. Right? Don't get rid of the parentheses. The parentheses make it readable, right? If you didn't have those parentheses, how are you going to read this? You're going to read it left to right, right? And then I've got an OR, and an and then I'm forced to go back to my big book of order of precedence operators, right? And then think about it really hard, right? And I don't like thinking about it really hard. I want to move on and get the rest of this done, right? So absolutely they're necessary for style and readability. Okay? But are they removing them will not change the logical outcome of the result. Can you get it down further? You can't do 0 lines, right? Could you get it down further? Well, yeah, by taking out all the white space, right? But could you get it down any further? I don't think so. Maybe. But then it'd be clever code and not at all readable code. Right? Okay, great. I've got my completely overlaps functionality here. Now let's go ahead and open up the file, process it line by line, and see how many of them evaluate to true. So file f is equal to new file. Right? Odd question, but what genre of music would you call this? Okay, so there was a question online about, I play music as an intro just to test the audio every single time. Ultimately, I cut it out of the recordings usually because there's a copyright violation. But if it was a performer named Tiny Tim, and so I don't know what you would call it. Stupid 80s or probably 70s. I forget when he died. I don't know. I'd have to look it up. I don't think that there's a genre. It's just novelty music, I guess. Right? Anyway, so not new file. What the hell am I doing? I'm still thinking of Java from this morning's section. All right. So how do I open up a file in C? Open. And what file are you going to open up? First of all, let's open it up for the testing one, right? day04.test.txt. And I'm opening it up for reading. Okay? Now let's go line by line, which means that I'm going to have to create a buffer. Big enough. I'm going to have to create an integer, or sorry, a pointer to tell me when I've hit the end of the file, the gets, right? I'm going to read into buffer at most 100 characters minus 1 for the null terminating character from the file f. Right? And while line is not equal to null, I'm going to read the next line at the end of this loop. Because now I want to process the current line, ... Now let's think about that. In order to process this line, something that looks like this, I want to extract those 4 numbers. I'm not really going to care about the hyphen. I'm not really going to care about the comma. Right? If you wanted to tokenize it, it would look something like this. Right? Int x is equal to a to I of strtok of buffer. And I'll go ahead and go with a hyphen here because that's the first token I care about. And then I'll go, let me call it A, right? And then we'll get B, right? And the second token that I care about is the comma in that line. And every time I subsequently call strtok, it'll be null. So it's going to look something like this, right? X and Y. Right? There we go. And the hyphen, comma, hyphen, there we go. And then comma, hyphen, doesn't matter, right? I'll just get the last one, right? So if you wanted to use strtok, as we've covered before, you can do something like this. I'm going to do it all in one line because we're playing code golf today, right? If you've got a line, a formatted line, if I were to print something like this, right? If I had A, B, C, or A, B, X, and Y, int A, B, X, and Y, right? If you wanted to print something like this, what would you use? Printf. And you would use a formatting that looks like this. %d hyphen comma, or %d comma, %d hyphen %d, right? And then you would print out x, a, b, x, and y. Well, I want to do the opposite. I don't want to output it. I want to input it. So what's the opposite of printf that we covered very briefly only at the beginning of the semester because nobody sits there mashing the keyboard for any real program? Scanf. Right? All right, so nobody's going to be mashing this keyboard either. I don't want scanf. But what other kind of printf did we look at? sprintf, that does output to a string. So let's combine those two ideas. Can you do input from a string? scanf. And yes, you can. Right? What this looks like is, here's the buffer. there's and there's an end-line character in there as well. There is the format that I'm expecting, and I want you to fill in these buckets. Remember with scanf, we put a bunch of ampersands here. Ampersand, ampersand, ampersand. That way, I get it all done in one line. Right? Now, are you going to use scanf on your final? No. I'm just showing you these little tricks here. I'm going to show you more tricks as we go along. Right? Because once you've gotten the basics from a CS1 class, you start looking for these tricks. Why? Because you don't want to do the same thing over and over and over again. Right? So let's actually make sure that it works, right? Because my scanf could actually be rusty here. Let's go ahead and go with printf, %d, actually 2%d, and %d, 2%d, and we'll go ahead and go have a result of %d and the line, right? And so I'm going to go a, b, x, and y, and also I'm going to capture that value. Bool result is equal to my function call completely overlaps of a, b, x, and y. So I want to test all of this all at once. Okay. So let's go ahead and day 04. Uh-oh. Okay. Yeah. What else would you call? Oh, I'm not actually printed it out. Right. I was going to say, you can format a true and false. I really highly doubt that. What's the result? There we go. Result. All right. There. It's going to be 0 or 1. All right, let's run it. Now remember, what should we expect here? I forget that no, 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 yes, yes, no. So 3 no's, 2 yeses, and a no. Okay? 3 no's, 2 yeses, and a no. And all of that looks like that file to me. So my scanf is not that rusty. scanf is not that rusty. Good. All right. So all that remains now is to maybe get rid of this ad hoc testing. Right? And instead of printing it out, so I don't want to get rid of that. Sorry. I want to get rid of the output that I produced for it. But if result, then I'll increment a counter. Right? Because remember, what we wanted to do is we wanted to add up the number of those number of lines that completely overlapped. So that means I'm going to have to create a counter. Is that a good idea, what I just did on line 17? What did I fail to do on line 17? Initialize it to 0. Also, be consistent about what you call it. So my count here should be 2 because this is still the test. And it's getting really slow. I don't know why. Great. Let's go ahead and go back to this and change it to the actual input. GCC. 571 out of the 1,000 are completely overlapping. Before I turn this in, let's improve this a little even more. All right? Well, I'm not the file kind of I/O guy. I'm not the kind of guy that likes doing file I/O over and over and over again. So what's an alternative solution here? Go back to hack 10, all right? And do what? Solve that problem once and for all, right? What's another solution? I refuse your input. I'm not going to do file I/O, right? So what I'm going to do instead is I'm going to take your input and I'm going to modify it, right? I want these to be arrays of integers. I don't want them to be, these ASCII text characters with hyphens and commas and stuff like that. So for the first thing I'm going to do is I'm going to replace all of your hyphens with commas. Everybody can do this on any text editor, right? Let me get rid of that for a second. There we go. So there are 2,000 of them, right? That makes sense because there are 1,000 lines and there are going to be 2 hyphens per line. So let's go ahead and replace all of those. Nearly there. Each one of them is not an array yet though, right? What I need to do is I need to make it look like this. I need a curly bracket in the beginning, a curly bracket at the end, and another comma at the end because this is going to be an array of arrays, right? Do that over 998 more times. You want to do that? Nope. Okay, undo, 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 undo. There must be a better way, right? And this is where this magic comes in. This magic called regular expressions. Over here, I'm going to turn on regular expressions. What I want to do is I want to take every line and I want to put a curly bracket at the beginning of the line, a closing curly bracket at the end of the line, and then a comma. And then whatever was on that line to begin with, I want to preserve it. Here's how I'm going to do it. Regular expressions use these special symbols that you just have to remember, and then when you forget them, just go back to a cheat sheet. And oh yeah, the beginning of the line is matched with a caret. The ending of a line is matched with a $sign. And unfortunately, there's no way for me to zoom in on this. Sorry. Right? I will put it up here, though, so that it's on the live stream. Right? That regular expression right there will match any empty line. You'll note here it's red because there are no results. There are no empty lines in this file. If I were to put one there and then go back over here, right, find, there. It matches that empty line and that empty line over and over and over again. Right? I don't have an empty line. I have a line with 4 numbers and 3 commas delimiting them. Okay? So what I'm going to do is I'm just going to call that a catch-all. The period matches any single character. The star after it matches 0 or more occurrences of whatever was just in front of it. So what this is doing is it's matching any any line period. Right? This will match all lines. Right? Now what I'm going to do is I'm going to take that match, right? Say on line 260 here, 21 through 95, and I'm going to preserve it by putting it inside these parentheses. Now I'm going to do my replacement. The replacement that I want is an opening curly bracket. Whatever was there before, $1 matches my grouping. So parentheses here. If I had multiple parentheses, right? Here's the first group, here's the second group, here's the third group, right? Then it would be $1, $2, $3, right? And then a closing curly bracket followed by a comma here. Replace all of those. We're getting darn close here. Right? Now up at the top here, I want this to be an array of arrays. There we go. Shut this off for a second. There we go. So it's no longer highlighting. Well, now I just need to do one line here. It's an array of arrays. Get rid of this last one here. Get rid of the trailing comma and close your array of arrays. Right? How big is it? Well, from my line numbering here, it tells me that there are 1,000 things in here, and it's a 1,000 by 4 integer array. Cool? Now I can come over here and completely replace, I'm just going to put it up here. Right, there we go. And I'm going to completely replace my file IO entirely. There we go. So there goes my while loop too. Right? Oh, I don't want my, don't lose my counter. There we go. Get rid of file IO stuff only. For int I equals 0, I is less than, what was it, 1,000? Right? I plus plus. Now don't forget 571. I want to make sure that I get the same exact answer as before. Now I don't need to read it in from the standard input. Instead, A, B, X, Y are going to be in, what did I call my array? I think I just called it ARR. So if I, 0, there's A. Right. B is equal to array, so if I, 1. C is equal to array, so if I, 2. D, or C, X and Y, sorry, is equal to array sub I 3. Done. Right. Now, 571, hopefully it compiles. Well, once I get rid of the rest of the file IO stuff, it will. There we go. 571, excellent. Right. So, writing a bunch of code to do file IO, or if it's just a one-off thing, like because you're just getting this done to try to get onto the leaderboard really quickly, right? Or you've just got this static data, or the main use case for something like this is test data, right? a lot of people, you know, probably did this manually where they created 5 airports or something. And so they had a template with empty strings, and then they'd cut, paste, cut, paste, cut, paste, and then they went back and they filled it in. Some people actually went the full 9 and you know, put that into a CSV file because they didn't want to cut and paste, and they didn't want to change it, and so they wanted to pull directly from a CSV file. That was fine too. You can do stuff like this if you learn regular expressions. So if you're taking, say, CSCE 251, I think that they go over basic regular expressions, and you can get a lot of stuff done, right? Even if it's just counting things. Like, for example, how many 2-digit numbers begin with a 2? Right? So here I'll go 0 through 9. There we go. All right. So how many 2-digit numbers begin with a 2? 325 of them. Right. How did I do that? 2, I hard-coded it. It needs to begin with a 2. 2 is required. But then I did a range, 0 through 9. Right? How many numbers begin with a 2 and are even? So they end with a 0, a 2, a 4, 6, and 8. 411? Is that right? Was that at least less than the other one? What was the other one? 411. There's something wrong here because, yeah. What is it? 0, 2. Oh, because I'm putting in a comma. 0, 2, 4, 6, 8. There we go. That's the correct regular expression. 153. There are 153 numbers that begin with a 2 and are even. Right? There's no comma in there. Like I said, once you learn about regular expressions, unless you're using them on a daily basis, you're not going to remember the syntax. I didn't, right? Instead, you vaguely remember that I can do this. How do I do it? I jump onto some cheat sheet. In fact, there was a nice website, I think I've got it somewhere, but that allowed you to debug regular expressions directly in the browser, and it'll even output like plain old English what this is actually mapping, along with like examples. And then you can go in and change it and get exactly what you want. You could do things like, say, immediately match anything that looks like a telephone number, match anything that looks like a web address, match anything that looks like an email address, right? And then you could do really powerful stuff. You could split up a telephone number into the area code, the prefix, and then the base number, right? And then you could put, do whatever you want with those those 3 pieces of data separately. Okay. 571, enough bells and whistles. Let's see if we're right. Because it doesn't matter at all if we're wrong, right? You could have all the tricks in the book, but still be wrong. Hey, all right, cool. Yay. Now let's see what kind of corner we've painted ourselves into by doing it quick and dirty. And let's see if this is going to be much harder on the second one here. It seems like there is still quite a bit of duplicate work planned. Instead, all the elves would like to know the number of pairs that overlap at all. Okay. In the above example, the first 2 pairs don't overlap, while the remaining 4 pairs do. They overlap partially, right? Remember this visualization? That doesn't overlap at all. That does not overlap at all. That overlaps in 1. That completely overlaps, and then this overlaps in 3. Right? So it's probably going to be more. Yeah, it's definitely more. So we know that 500, if we get anything that's less than 571, then we know that it's wrong. Right? And so the answer here is 4. How many assignment pairs do the ranges overlap? My forethought here in putting that kind of logic into a separate function is now going to pay off. Why? Cut, paste, and call it something different. Partially overlaps. Do I have to change anything down here other than my call to my function? Nope. I've been able to reuse everything. Now all I have to do is figure out this logic here. Oh, oops, not that one. That one. Help me out. How do we know if they partially overlap? False, right? False, true, 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 right? So I could take this partial answer here, right? If it completely overlaps, well, then it partially overlaps, right? A, B, X, Y, and I'll return true. I'll simplify this later. Else if, what's the other condition? And then else, return false. Right. So the other conditions are when they're only they're not completely contained in, but they're partially contained in. When it looks like this, or when it looks like this. Okay? So help me out with respect to A, B, X, Y. What is that going to look like? Let's visualize it here generally, right? This does a great job of visualizing these specific examples. Now what our job is to generalize this logic, right? And you're eventually going to take discrete math. That's exactly what proofs are. When you're proving something in math, you think about a specific example, and then you take away the things that make it too specific. You generalize it, and you've come up with a general proof. Right? So what does it look like here? Right? A, dot, 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 X, dot, 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 Y, dot, 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 B. Sorry, B, dot, 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 Y. Right? There we go. So here, X to Y is our one interval. A to B is our other interval. And they intersect right here. Right? Right? So that's one condition. How do we codify that with the actual numbers here? All right, so I'm going to go left to right. B is greater than or equal to, right? Because if they match, then they still are there, right? Okay. Do we need to consider anything else? So is that an and? Y is greater than or equal to greater. Oh no, A is less than or equal to Y. In fact, do we need anything else? I just need to know that X lies between A and B, right? Then we would have something like this, and then now A is greater than B, though. And we know that they're not going to give us bad input, right? So we're going to assume that the input is correct, that A and B are less than or equal to each other already, right? They wouldn't give us bad input, would they? Hopefully not. I think it's just simply that the one endpoint has to lie within the range of the other, right? If this endpoint lies within this, or if this endpoint lies within this, right? So if A is less than or equal to X, is less than or equal to B. Is that valid C code, by the way? Nope, that goes back to like week 2, where I showed you, hey, if you turn on this wall flag, it'll tell you that this is stupid. Right? Let me show you again, right? Wall. There we go. Comparisons like that do not have their mathematical meaning. This isn't math. This is computer science. This is programming. How do I do this? I split it up. There we go. So that means that X lies within A and B. What's the other condition? Let me put that in parentheses here. Or, what's the other condition here? That I've got, say, X dot 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 A dot 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 Y dot 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 B. There we go. A has to lie within X and Y. There we go. So X less than or equal to A, and A is less than or equal to Y. There we go. That takes care of that one. Let's be consistent about this. Are there any other possibilities that I'm not thinking of? I think there are 2 other possibilities, aren't there? No, we start with A, and I guess you could have X, A, Y. Nope, I think that's it. Return true. Well, sanity check here. let's at least get a count on these. It should be at least 571, 917. Let's go for broke. I'm a gambling man as long as it's not my real money. Right. Submit. Yay, we did it. Right. So that either means that we were really good or that they didn't have a good test case to prove us wrong, right? All right, I'm up to 8 gold stars now. We've got 15 minutes left. This will require me reading for this from scratch, though. The expedition can depart as soon as the final supplies been unloaded from the ship. Supplies are stored in stacks of marked crates, but because the needed supplies are buried under many other crates, the crates need to be rearranged. Oh, you know what? I mean, this is going to get harder and harder here. Let me go back to something that the one that we did this morning here, which is basically just string processing. I'm not repeating myself here because I actually didn't do this in C. We did this in Java. Right? So let's redo this in C. If you want to watch that live stream from this morning and see the Java version, great. But the idea here is that you've got a bunch of these random strings. They're all uppercase and lowercase letters. They're all of even length. Because what it wants you to do is it wants you to split these out. I'm going to get rid of all this. All right, and where is the even split there? Yeah, there's the even split. Now, in the first exercise here, what you have to do is you have to find either the uppercase or the lowercase, it is case sensitive, letter that is common to both the first half and the second half. In this case, it's P. There we go. There's P and P. Right. All of those other letters, capital W, lowercase f, uppercase f, right? They only appear in either the first half or the second half. Okay. All right. So what we need to do is we need to go through this input right here. This is the test input. And we have to count up the number of letters, lowercase items or uppercase items that are in both halves. Okay. I think we could do this in 10 minutes, especially if we do a speed run using some regular expressions. Right? But in any case, you have this score because you still have to report one single number. Okay. Here, my answer was 7850. Let's see if we get the same one. I'm not going to be able to resubmit it, but we'll be able to check to see if it's correct. Right? So your score is based on what if it's a lowercase letter, that has priorities 1 through 26. So, for example, P is the 16th letter, right? Then that would be 16. L is the 12th letter, but because it's a capital, it maps from 27 through 52, and so it has a score of 38. Okay? So let's come over here and copy day 04.c into day 03.c. And let's get rid of this stuff. All of this stuff. Come on. Jeez. Should have just started with a clean file, damn it. All right, there we go. Now, before we even get started with the file IO or the actual input, let's, again, think ahead to what the functions we want. Okay? I want to know which character appears in both the lower half and the upper half. So I want to design a function that has a common character. Right? And it's going to find that character and return it for me. And it's going to take this const char star string. Okay? To split it up into two halves, I need to make sure that, well, I could check to see if it's even, but trust me, they don't give you bad input. So, but I need that length, first of all. Int n is equal to strlen of s. Right? Now, if it's 10, I want to look from 0 to 4, right? And 5 to 9. And for each character over here, I'm going to see if it appears over here. And if it does, we're good to go. Right? All right, so for int I equals 0, I is less than something, I plus plus. Right? I'm going to check to see if the ith character, which is an s sub I, is in the second half. Right? So if s sub I is in the string from some value up here up to n minus 1. then return true. I still have my standard Boolean library here. Okay. Not return true. Return what? S of I. There we go. Help me translate this. How do I check this over here? Well, first of all, where do I want to start and where do I want to end? I want to go all the way to n minus 1. But this sounds not like an if statement. It sounds like an if and another loop. For int j, starting somewhere, right? That's that question mark. J is less than n, j plus plus. Right? Now I can check if s of I is equal to s of j. That means that we've got the same character appearing in the first half, this ith one, and it's equal to whatever j we're checking over here. So I'll return s of I. Oops, s of I. There we go. Now help me. Where do I go up to and where do I start next? So again, the idea with a lot of coding and with a lot of the secret, in fact, we were just having a discussion about this at the at our potluck, right? That some students were having problems in upper level classes thinking more abstractly, thinking about proofs, right? Well, what is n? What does n stand for, right? I don't know. Well, what does n stand for here? Right? Is it 200? Is it 1,000? You don't. Why even think in those terms, right? It's n. Right? It's just algebra, right? Okay. So how do I go halfway? Sometimes it's easy. It's nice to take a step back and say, well, what if it were 200? What if it were 1,000? Right? What if n were 10? Then what are my indices again? 0 through 4 and then 5 through 9. How did I get there? N divided by 2, right? That's going to split it into 2. But now you need to think like a computer scientist. Now you need to think like a C programmer or a Java programmer or whatever, where you have integer truncation. 10 divided by 2 is going to give me what? 5. Do I want that? Nope. So I go up to and including n divided by 2 minus 1. But then, you think like a computer scientist. Minus 1. That's if I did less than or equal to. This is why we write idiomatic for loops, right? Because it always stops one less. Because of 0 indexing. Okay? Now, where do I go? Where do I start over here? Here now I do start at n divided by 2 plus 1. Right? Get rid of my cruft here. Should be doing that on a piece of paper anyway, right? Okay. Is this correct? Looks like it's me. Right? Let's come down here and did I want to count? No, I didn't want to counter. I did want a grand total though. Grand total. Right? And we will go ahead and iterate over all those, but I don't want to do any file I/O because we only have 7 minutes left. And so I will print out a grand total here. Let's come over here to the test input. I'm missing a V. Help me remember that. I'm missing a V. There we go. All right. How could I change this into an array of strings so that I don't have to do any file I/O? Same tricks that I did before. But what begins at the beginning of the line now? Star, sorry. And then the end of the line. And we have enabled regular expressions here. I begin the line with a double quote, whatever was there before, double quote, comma, right? And replace all. There, now it's an array of strings. Of what size? Char, star, I'm not going to be able to do it like that. Char character array of, how many were there? 6. And I'll just make it big enough. There's nothing more than 100 here. Str is equal to this, and then end it down here. There we go. Copy, paste over here. Right. Globals are evil. Do not do that in real life. Right. But now I can go ahead and iterate over it. For int I equals 0, I is less than 6, I plus plus. For each one of those strings, char C is equal to what I call it, common character. I want to know what the common character is in the ith string. There we go. printf c is equal to percent %c and the line c. Let's see if this is actually working. GCC. Oh, no, GCC day 3, sorry. STR, what's wrong? char. STR, there we go. What am I doing? Terrible syntax. There we go. There. So it should be lowercase p l p v t s. Is that correct? P l p v t s. We're good on the testing input. Now what we need to do is sum up all the scores, right? So once we've got this C here, right? If it's a lowercase a, I want to map it to 1. If it's a lowercase b, I want to map it to 2. If it's a lowercase c, I want to map it to 3. Right? Should I write this one big giant if-else-if statement or something like that saying if it's a, then its value is 1. If it's b, then its value is 2. Right? Or what could I do? ASCII table. Lowercase a is going to have what value? Do you remember? 97. So to map that back to 1, what will it be? 97 minus 96. So if is lower of c, it's a lowercase number, then the score will end up being c minus, I said 96, right? Else if it's upper, then how do we offset it? Uppercase is 65, so I minus, not 64, because remember we want to map it to what? 27. So 65 minus 27, that's what I need to offset it by. What is that? 38? C minus 38? Please tell me that's right. Yes? Well, add back 27. That's 65. That's what I got, right? There we go. And so I need a score here, int score. And then the grand total plus equals score. Only got 3 minutes here, so screw the printing. GCC this, run it. I got 157. 157. If I switch this over to the actual input, where is my input? Go back over here. Do the same exact find and replace. There we go. Change this so that it is a char str. How many are there here? Darn it. 300? 300 by, we'll just make it big enough, 100. Str is equal to this. There we go. There's my input. There's my new input for this. And change this from 6 to 300. Common character, GCC. Oh. What do you mean? It's not declared. It's right here, isn't it? str. Oh. There. Terrible syntax today. Sorry. GCC. There we go. And what was my answer? 7850 or something? Uh-oh. No, darn it. 7850. Why did I get the wrong answer?
I think in the function we subtracted 1.
Oh, where?
4 and j equals 2 plus 1.
And divided by 2? Bingo. Yeah, there we go. Thank you. Hey, 7850. Excellent. Right. And there's no way for me to resubmit it in a different language, but I do believe if you're interested in this, I think that well, first of all, you should be doing it anyway, just for fun or whatever, but there is a subreddit that will post answers, so if you get stuck, you can go ahead and go to that. On our Student Advisory Board Discord, there is a channel for it as well, because it's popular enough that people are talking. Well, no, our Discord is kind of dead, so give it some life, right? Actually join the Discord and start asking questions and interacting, right? I have nothing to do with the Discord. I'm on the Discord. but I have nothing to do with it. Right? Any questions? Otherwise, thank you for the semester, and good luck on your final, and good luck on the rest of your finals as well. All right, have a good break.